Hello everyone, welcome to my channel. This is for educational purposes, and we generally look at different kinds of theories of everything. We've been taking a deep dive into the reciprocal system of theory, which is a system of theory that was originated by Dewey B. Larson back in the 20th century. He left behind a lot of books and articles, mostly on scientific topics, but some other topics as well. And they stem from his original fundamental postulates that he came out with in the late 1950s. And the first postulate is basically that we live in a universe of motion. The universe is not made out of matter nor energy. It is made out of motion. Matter and energy are two different kinds of motion, along with all the other different scientific quantities that you know of. They're all kinds of motion. And motion, in Larson's formulation, is the relationship between space and time. So we can see that in speed. Speed, 20 miles per hour. It's 20 miles of space in 1 hour of time. Space over time, that equals speed. Speed is the most basic kind of motion that we know of. But all the other scientific quantities are also relationships between space and time. Energy is time over space. It took me 3 hours to move that thing 20 feet. 3 hours of time, 20 feet of space. That's energy. Matter is time to the third power over space to the third power. And that reflects the first part of Larson's postulate there, that space and time are both coordinate. Coordinate space, we're accustomed to that, XYZ coordinates, 3 dimensions of space. And also coordinate time, 3 or more dimensions of time. And you see that in the equation there. Matter is time to the third power over space to the third power. Basically 3-dimensional energy. And all other kinds, resistance is time to the second power over space to the third power. We've got pressure, time over space to the fourth power. Impulse is space to the second power over time. So on and so forth. Acceleration is space over time to the second power. And capacitance is space to the third power over time. Although Larson would dispute that, would have disputed that had he lived to this day, but he died back in 1990. And since the time that he died, other people have come along and have carried his work forward. And we're looking at one of those people today, Dr. Bruce Perret. And but just before I do that, let me finish Larson's first postulate. Space and time are both coordinate. They are also both scalar. They progress scalarly, what Larson calls clock time and clock space. The clock of time we recognize to be always moving forward, always progressing. It's always getting later and later and later. So too is space. Space is always getting farther and farther and farther apart, which the Hubble telescope observed as the recession of the distant galaxies. And then space and time also only come in discrete units. There's a minimum unit of space and a minimum unit of time. And less than that, you don't have time and you don't have space. If you have less than 1 unit of space, then you don't have space and you only have time. And if you have less than 1 unit of time, then you don't have time and you only have space. Because everything is made out of motion, and motion is the relationship between space and time. So everything is made out of either space or time. And space and time are not the container of the universe. Rather, they are actually the contents of the universe. And then also, if you have one unit of space in one unit of time, we've already established space over time is speed. If you have one unit of space in one unit of time, you have the speed of light. So the speed of light is what Larson calls unit speed. And the speed of light in Larson's formulation is the midpoint of the universe. There is half the universe that's moving faster than the speed of light, which Larson refers to as the cosmic sector, and half the universe which is moving slower than the speed of light, which Larson refers to as the material sector. The legacy scientists generally only know about the material sector, such as Einstein, who said that the speed of light is the maximum speed of the universe. This shows that he didn't know anything about the part of the universe that's moving faster than the speed of light. But we can understand that sector, the cosmic sector, very well through the process of extrapolation. Because of the reciprocal relationship between space and time, all we have to do is recognize that what's going on in the cosmic sector is exactly the same thing that what is going on in the material sector, which we already know about. We just have to reverse the roles of space and time. So, for example, in the material sector, you have 3 dimensions of space or more, coordinate space, and you have clock time, progressing time, always getting later and later. That's in the material sector. If you cross over to the cosmic sector, then you have to reverse the roles of space and time. So in the cosmic sector, you have coordinate time, 3 or more dimensions of time, and you have clock space, progressing space. Space is always getting farther and farther apart. So you have the same relationships there, except that the roles of space and time are reversed. Okay, now Larson took those original postulates, or that's the first one. The second one is just that the universe conforms to the relationships of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. Now, this postulate has basically been set aside by some of the followers of the reciprocal system now because they don't think that it's really terribly necessary, and that it is terribly accurate because Dr. Perret, for example, believes that the universe is projective, of which Euclidean geometry is just a subset of projective geometry. There's a geometrical cascade going from projective geometry to affine geometry to metric geometry to Euclidean geometry. Okay, and that's not the only thing that Dr. Perret disagreed with Larson, but Larson basically took his postulates and he used a deductive approach to identify an entire theoretical universe, which he develops in his books on physics and chemistry and astronomy and even economics, and then compare his theoretical universe with the actual universe. Usually very similar answers were derived by both, except that Larson's stood out and provided answers to questions in the realms of the very small, the very large, the very fast, and the very slow, that the Newtonian system didn't get to. So it's kind of like a replacement for the relativistic system of Einstein. Newton got most of it right, except on the margins in the extreme situations. And in those cases, a different theory is needed. or like, some kind of addition to Newton's theory is needed, and that's where Larson comes in. That's where Einstein came in, but Einstein's theories didn't work, and so uh, the reciprocal system is a replacement for those things. Okay, now Dr. Perret wrote under the pen name sometimes of Daniel Phoenix III, who was supposed to be a black ops computer programmer for the Montauk Project, time travel, secret government time travel project from the 1980s, and I suppose also the 1940s. And I don't know whether Dr. Perret was actually part of that, or that's just a character that he's taking on. But he writes about these articles this is the fourth and final article in his series called Anthropology: The Hidden History of Homo Sapiens, or Hidden Origins of Homo Sapiens. And we are looking at some of the stuff he's talking about here about astronomy. Now, what Perret is contending is that all the galaxies that we see out in space, that they are not galaxies, but they are actually solar systems, suns that are being orbited by planets. Not the core of a galaxy being rotated by a bunch of stars, but actually just stars just planets, or just stars being orbited by planets, and that they are orders of magnitude closer to us than we think they are. And he uses the concept of the index of refraction, that there's basically a difference once you get beyond the gravitational limit, which is something that was derived from Larson derived, and it's basically analogous to the difference between being in a liquid medium and being in a gas medium, or the difference between being in water and being in the air. And that if you look into the water, what you see is not what's really there, because the image is refracted. So the light is refracted, and you see objects that are closer or further apart than they really are, depending on which direction you're going. And so he's saying if you're observing stars or galaxies that are outside of the gravitational limit, you see them as being much farther away than they really are, by orders of magnitude. So, the legacy scientists will tell you that the Andromeda galaxy is 2 million light years away. And he's saying that it is. I'm not exactly sure where Perret says it is, but I think he says that it's less than 1 light year away. Not quite sure on that. He might get into that in this article here. But so we're going to take over, starting from that original set of that discussion that he got into in the last episode, having to do with the index of refraction and how far away all of these stars and galaxies are, and what they are, whether they are actually galaxies or are they solar systems. Okay, these natural consequences create a very different picture of the universe in which we live. We are no longer isolated and alone, but in the midst of many thousands of solar systems that all have similar conditions to our own. Life may not only exist out there, but in all probability will be very abundant. This simpler view of astronomy solves a number of problems with both conventional theory and intervention theory. 1. There are thousands, if not millions, of so-called galactic solar systems within range of our telescopes. 2, they are nearby and within range of arc technology, as well as our own electrogravitic spacecraft. Yeah, here he says that refraction corrected approximations put the Andromeda solar system a mere 3 light months away. Okay, so it used to be 2 million light years away, and Perret is suggesting that it is one now, with these new corrections, that it is actually only 1/4 of a light year away. 3, supermassive black holes are no longer needed to hold together billions of stars in a galaxy, since it's actually just a small solar system like our own. 4, wormholes and warp drives become unnecessary. Travel between stars takes about the same amount of time the ancient mariners took to sail between Europe and America. 5, no longer a need for dark matter to account for missing mass, because the scale was wrong and there is no mass missing. 6, no need for dark energy to push things apart. The progression of the natural reference system already accounts for that in totality. 7, many points of light we see in the sky are just asteroids being lit up by the sun, typically highly reflective gas giants formed from the supernova debris field that created the solar system. 8, what we now view as the Milky Way galaxy is just another solar system that is gravitationally bound to our own. Many so-called galaxies are in the same situation. All the antenna and mice galaxies, they are just solar systems within the gravitational limits of each other. 9, other actual stars have been misidentified as quasars. Larson's research into quasi-stellar objects, or quasars, showed that the redshift measurements were fudged by astronomers, and the redshifts indicated these objects are actually quite close, not at the extreme limits of the universe. 2, real galaxies do exist, having been identified as quasar galaxies, galaxies made of quasars. When scaled down, the quasars become the stars of the galaxy. And 11, the extreme orbital speeds of exoplanets become scaled down to moons orbiting Jupiter-like planets at the normal speeds observed in our own solar system. As an example to item number 11, we can take a conventional star with known exoplanets, such as Kepler 101, a single sun with 2 planets, 101b and 101c. 101b orbits this star in 3.49 days, and 101c in just 6.03 days. The fastest planet we have in our solar system is Mercury, taking 88 days. That's a big difference. But what if we scale the star Kepler 101 down to a Jupiter-sized planet? Jupiter has a bunch of moons, and it is a Jupiter, and if it is a Jupiter-sized planet, 101b and 101c should show similar orbital properties as some of Jupiter's moons. Jupiter is roughly 1/10 the size of the Sun, so we can adjust the orbital distance by a factor of 10. So take out a factor of 10, 101b becomes 0.0045 astronomical units. 101c becomes 0.00648 astronomical units. So we are looking for a couple of moons at these distances with similar orbital periods. The period is not scaled as it is time, not spatial distance. So 101b, the period is 3.49 days. 101c, 6.03 days. Lo and behold, if you look at Jupiter's moons, Europa has the exact same distance as 101b, and its period is 3.55 days as opposed to 3.49 days. So it's off by, a factor of an hour and a half, basically. Almost an exact match to Kepler 101b. And if we look at the moon, Jupiter's moon Ganymede, Ganymede is 0.00716 astronomical units, and its period is 7.15 days. Just a little farther out than Kepler's 101c, which was 6.03 days. To paraphrase Obi-Wan Kenobi, that's no planet, it's a moon. And a moon orbits a larger planet, not a star. What they found are not exoplanets around stars far, far away, but moons around large planets close, close nearby. As hard as it may be to believe, it looks like the experts did it again and got everything wrong. I know how surprised you must be. But with this new perspective of Astronomy 2.0, we actually live in a rather crowded section of space. Initial estimates place over 1,200 solar systems within a 5-year mission of electrogravitic ships that can travel at near light speed. All these stories of UFOs and ETs may well be true, and with the potential of hundreds of different civilizations paying us a visit, it certainly explains the wide variety of different craft designs. However, I still have my doubts about channelers because I could not help but notice that these hyper-intelligent, pan-dimensional beings never bothered to tell us that we got our scale wrong and that galaxies were actually solar systems. Though it did appear that Ra, channeled through Carla Ruckert and questioned by Don Elkins in the 1980s, made the attempt, but we were so programmed into the galaxy mode of thinking that we never connected the dots. And if you look at the Ra material, which is the channeled work that he's talking about, Ra material 1635, Ra, I am Ra. I see the confusion. We have difficulty with your language. The galaxy term must be split. We call galaxy that vibrational complex that is local. Thus, your sun is what we would call the center of a galaxy. We see you have another meaning for this term. Elkins, would you define the word galaxy as you just used it? Ra, I am Ra. We use that term in the same sense as you would use star systems. Okay, I think I'm going to stop there. I just wanted to point out he didn't mention this in his list of 11 things, but I think he will probably talk about it later in this paper. This concept that he has here of the solar systems all being the same fundamentally, with inner planets and an asteroid belt and outer planets, and that the stars that we thought, a lot of the stars that we thought were out there were actually planets or being orbited by moons, and a lot of the galaxies that we thought were out there were actually solar systems or suns being orbited by planets, um, that throws a very serious wrench in intervention theory. Zecharia Sitchin's idea of the 12th planet, and that it came into the solar system and it whacked the crap out of uh, what was it? I guess Tiamat, and broke Tiamat into a bazillion pieces, one of which became Earth and the moon, and or its satellite became the moon, and the rest of it became an asteroid belt, or much of the rest of it became the asteroid belt. Um, it throws a lot of cold water on that theory, and because Perret is saying that the asteroid belt is a natural feature of a solar system, in exactly the same way that a ring around Saturn is the natural result of a planet. So, or a certain kind of planet. Anyway, not all planets have rings. Um, they have to meet certain conditions, but the concept of a ring around a planet is the same as the concept of an asteroid belt around a sun, and I believe that it would represent the at least one of the gravitational limits that Larson talks about. Okay. Um, Thanks for tuning in. We will take over here at this juncture next time. Now, just keep in mind, I am going to be putting out another video in our Cardiomaniac series. Maybe 2 more videos in the Cardiomaniac series, which I guess will be debuting on BitChute, but I've put out about 3 of them on YouTube. And these are really designed to showcase my level of fitness and endurance. Not so much, you know, for that specifically, but if you strive to have that kind of level of fitness and endurance, you may want to hire me as your strength and conditioning coach, especially if you are the coach of some kind of a team, especially a basketball team or a soccer team, or any team that relies on, top-notch conditioning. And it is also kind of an advertisement for my diet. It's my diet that enables me to do the things that I do in the gym with cardio, endurance exercise. And so I'm just trying to document that with those videos, and to, get people to speculate on how I'm able to go that fast, that far at my age, and to note to you that I can teach you to do it, and I can teach your team to do it also. And if you have a basketball team, for example, and you guys have that kind of level of endurance, you'll just run another team right off the court. I mean, they'll play with you for the first quarter. By the second quarter, they'll be losing it, and by the second half, especially the fourth quarter, it'll be completely over. And you'll be the only ones running out there. They'll be just drooping. So same with soccer, and probably many other sports too. Okay, just an aside there. Just keep your eyes on that if you want to watch my endurance videos. They're rather boring, I guess, and they'll make you tired just watching them. But they are evidence of highly high level of fitness. Okay, have a great day. Talk to you tomorrow.